Hello everyone, welcome to CodeChef. Myself Jala Churasia and today we are gonna solve the problem which came into starters 205. The name of the problem is Triplet Maximization and the problem code is MAX123. The difficulty rating of the problem is Cakewalk and the prerequisite is at all. Let's start with reading the problem statement over here. So guys, problem says chef has an array A of length x plus y. The first x elements of this array are equal to 1 and the remaining y elements are equal to 2. That is, the array satisfies a1 equal to a2 up till a of x which is equals to 1 and a of x plus 1 equal to x plus 5 which is equal to 2. Further, it is guaranteed that x plus y is a multiple of 3. Chef will then perform the following process. Let S be set of integers. Initially, S is empty. Chef also has a score which starts at 0, while the size of S is less than x plus y. Choose three indices I, J, K such that I, J, K lies from 1 to x plus y and none of I, J, K are present in S. Then add a maximum of A of I, A of J, A of K to his score. Essentially, Chef repeatedly chooses three elements that all haven't been chosen before and adds their maximum to his score. This continues till each element has been chosen exactly once. Find maximum possible score Chef can attain if he chooses index triples optimally. If input format, the first line of input will contain a single integer t denoting the number of test cases. Each test case consists of a single line of input containing two space separate integers x and y, the number of ones and the number of twos in the array respectively. Output format for each test case, output a new line, the maximum possible score Chef can attain. Constraint for t lies from 1 to 3400 for x, y lies from 1 to 0 to 100, x plus y is a multiple of 3. So guys, now let's understand the sample test case. The question more precisely over here. So guys, this question is pretty much straightforward to understand. It says some Chef has an array of length, let's say x plus y, and the first x elements of this arrays are equal to 1 and the other are, that is the y elements are 2. Okay, so this is how the array will look. And the x plus y, this is the count of 1 and 2, their count would be multiple of 3. Their sum would be the multiple of 3 only. Okay, so Chef will then can perform this operation that let us be a set of integers. Finally, S is empty. Initially, S is always empty. Okay. So Chef has also the score which start at 0. So while the size of S is lesser than x plus y, we can choose three indices where three indices lies from this 1 to x plus y. And IJK are present are in none of the IJK are present in S, basically no repeated elements. And we have to add maximum of A of I to his score. So we have to find the maximum possible score Chef can attain if we choose index triples optimally, right? Now let's take the first test case. We have got x, y, which is 0, 3, cool. So the array will look like something 2, 2, 2, right? So Chef's only choice is to choose all three elements, I, J, K, and add their maximum to his score. So the maximum would be 2. So guys, I think you can see over here, output is 2. So guys, I think the test cases are pretty much clear. Now let's move for the simple solution. So let n equal to x plus y be the length of the array. We must then choose exactly n by 3 triplets spanning all n elements. Since each element is either 1 or 2, observe that the score of a triplet will be 2 if at least one of its elements is 2 and will be 1 only if all three elements are 1. We want to maximize the score, so naturally it makes sense to try and maximize the number of triplets with score 2. Let's think about when we can make every triplet have a score of 2. There are n by 3 triplets, so we certainly need at least n by 3 occurrence of 2 since we will need to give an occurrence to each triplet. It's now easy to see that if this condition is satisfied, that is, we have at least n by 3 occurrence of 2, we can surely make every triplet have a score of 2. Just give an occurrence of each triplet and then distribute the remaining elements however you like. Thus, if y is greater than or equal to n by 3, the answer is simply 2 times of n by 3 since we will have n by 3 triplets with a score of 2 each. That leaves the case of y lesser than n by 3. Here we can only have y triplets with a score of 2 by giving one occurrence of 2 to each of y distinct triplets. This is also clearly the best we can do, hence n by 3 minus y triplets remaining which we will have a score of 1. So the answer in this case would be twice of y plus n by 3 minus y which will be equal to n by 3 plus y. To summarize, if y is greater than equal to n by 3, the answer is twice of n by 3, otherwise the answer is n by 3 plus y. So we can technically avoid having to case solve with nothing that is equivalent to the expression n by 3 plus minimum of y comma n by 3. So guys, I think the solution is pretty much clear. Simple ad hoc solution guys. Now let's move forward the simple C++ code. So guys, this is my simple C++ code. I took the input for all the test cases as well as x comma y. In this n variable, I initialize x plus y, and over here I am checking the condition if y is greater than or equal to n by 3. If that's the case, I will print twice of n by 3, and other case I will print y plus n by 3. And as you can see that guys, I have got my C++ code right now. Let's move to the Python code. So guys, this is my similar Python code. I took the input for all the test cases as well as x comma y. I initialize n equal to x plus y. And over here in this if condition, I'm checking if y is greater than or equal to n by 3. I will simply print twice of n by 3. In all the other case, I will simply print y plus n by 3. And as you can see that guys, I have got my Python code right. So guys, I think the solution to code and the approach was pretty much clear. Now let's meet in the next video. Thank you so much guys for watching our videos.